Okay, so yesterday, pi radians, 180 degrees, right? That's our big thing we're going to base this all off of. Okay, so what you're going to do is you're going to convert from degrees to radians. So here we go. 70 degrees is how many radians? That's kind of my question, right? And then what do I know? I know 180 degrees is pi radians. Okay, so how do we solve something like this? What's a good strategy? Anybody have? Starts with a C. Cross multiply. So this times this divided by that. So 70 times pi over, and then divide by 180. So I'm going to have to times by pi, divide by 180. Okay, do you remember that you have to do this to 3 decimal places? See if we can get to 3 decimals on your calculator accurately. Does that radian number make sense? Do you remember, so 70 would be like that. Do you remember what this top line was in radians? Up here, the 90-degree area. What was that? 1.5-ish? Yeah, because pi divided by 2, right, was 1.5-ish. So 1.222, that makes sense. Okay, so this one, we're going to go from radians to degrees. So this time I'm going to go 2.93 radians is how many degrees? When I know the what. And then I'm going to write down the what. What do I know? I know pi is 180. So I do the what do I want to figure out, and I do the what do I know times divide. Okay, I'm done showing you this the long way. That was the long way. I made a proportion, I did a cross multiply. So here's what I always do. You have 2 choices. These are your 2 scenarios. You're either going to times by pi and divide by 180, or you're going to times by 180 and divide by pi. Okay, those are the 2 options. Okay, my trick is to divide by what I want to get rid of. Okay, so 144 degrees. So I'm going to times it by, and I'm going to either do pi over 180 or 180 over pi. So I want to divide by, what do I want to get rid of? I want to get rid of the 180 degree because I want to get rid of degrees. So then that's what I'm typing. Okay? Okay, you should ask yourself if your radian numbers make sense. To me, that does, because I know 180 is about 3.14, right? So I'm less than that. Okay, any predictions with 5 radians? You guys remember where 5 would go? So we talked, this was about 1.5-ish. This was 3.14. Right, a pi. How much? Should I go to the bottom? Do you remember the bottom number? That was 4.7-ish. Okay. So that's where the 5 landed. Prediction? You know, 290, I don't know, something bigger than 270, right? Okay, so here we go. 5 times which fraction? 180 pi, pi 180. 180 over pi, because I'm in radians, so therefore I'm going to divide by a radian to get that out. Ooh, look at my prediction. That was pretty close. I said 290 was my estimate, so. Okay. Are we okay to skip one? Is that fine? It's nothing new. I'm going to do this last one, though. This is in radians right now. So I'm going to times by what fraction. If I'm in radians, then I want to get rid of radians. Okay, I'm going to show you this one because this one I probably would have to do without my calculator if I saw this question. Okay, why can I do this one without my calculator? What could happen here? Cancel the pi's. Could you take those values and reduce them? 180 and a 3. So if I divided this by 3, it could be a 1. And if I divided that by 3, it would be 60. And then the 60, and I still have to times it by that 2 there, because that wasn't canceled. Okay, 2/3 of a pi. So remember that this is a pi. So what does it look like if you go 2/3 of that? So if I cut it into thirds, right? If I cut something into thirds, 1, 2 thirds, right? 2/3 of the way. Okay, so yesterday, do you remember we did that with the radians? Okay, I'm going to practice that again today on a different paper. Okay, let's do these ones at the bottom then. Okay, so yesterday when we started chunking our radians into sections, right, we talked about pi over 6 was the same thing as 30 because 180 over 6, right? That's why that's an over 6 number. Okay, then do you remember what I did here? I told you that 1 pi could be thought of as a 6 over a 6. So that is why I came up with 5 over 6 here and 7 over 6 here. Then over in this spot, when I did 2 pi, I changed that in my head to be 12 over 6, hence why this is 11 over 6. Okay, does that all make sense? And I just repeated that same idea, obviously, with the fourths and the thirds. Okay, so 7 pi over 3 is my first drawing. What do you know? What's your first instinct when you see that 7 over 3 value right there? More than its full circle. Okay, so here's what I know. 2 pi would be what to match this fraction? 6 over 3, and that is bigger than doing that. So you're going to go a whole circle, right? And then you have to do one more to make that 7. So a full circle, then pi over 3 extra. So that's the idea. Question B, negative. So as soon as we see negative, we do our rotation downward. Okay, what do I know about that value? 2/3 of a pi. Okay, it's not even a half circle. It's 2/3 of a pi. So 2/3 of a pi. Okay, ooh, negative, so I know rotational go downward. Okay, I'm going to start spinning. You ready? That is a pi. That's a negative pi. 6/6 right now. Right? Pi. 1 is 6/6. Here we go. I'm going to go to this, which is 2 pi, which is 12/6, right? 6/6, 12/6. What if I go another semicircle? What would my number be now? 18 pi/6. And 19. So see how I broke that down? Okay, all this without a calculator too, right? So 6/6 was the 1 pi, 12/6 consists of 2 pi, a full circle. Okay, and then I kept going. Okay, can you grab a unit circle? Do you have a blank page yesterday or something? Okay, so when you're doing this unit circle, you have to have everything on there memorized. So let's go degrees first. So 0, 30, 45, 60, 90. Okay, does everybody have like a blank one somewhere? Right? Okay, I'm going to keep going. 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, and 330. Finish off 360. Okay, radians need to go on your unit circle. So I'm going to do the 4 sections. 0, pi/2, 1 pi, 3 pi/2, 2 pi. Okay, so now I've put all my 30 degrees spots, so my 30 referenced, they're all yellow. What do they all have on the bottom of them, the 30 degrees? We have a 6. Okay, so we're going to go pi/6. An entire pi over here is the 6/6. Therefore, we get to do a 5/6 and a 7/6 around it. If I did a whole thing, would be 12/6, so 11/6. Okay, so, whoops, wrong spot here. I wanted to do all my 45s. All my 45s, okay, so 45 is with a 4 fraction, 180 divided by 4. Okay, so in my head, I'm calling this over here 4 over 4. Therefore, this is 3 pi over 4, 5 pi over 4. The full thing would be 8 over 4, thus 7. 7 over 4. And then you're going to do all the 60-degree spots. So 60 comes from 180 divided by 3. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so we basically did all that yesterday yet, but now we didn't have time to do the coordinates, so this is a recap of grade 11. I'm going to do the 4 quadrant spots. So over here at 0, we're 1 to the x, 0 height. We are located 1 right, 0 up. If we go to the 90, our x is 0, but our height is 1. At 180, you're left, no height. And at the bottom, no x, down 1. Okay, our pattern on a unit circle, all this has to be memorized. Do you remember that pattern? Zero, 1/2, root 2 over 2, root 3 over 2, and 1. Okay, so here is what I kind of showed you in grade 11. So I go x. So if x is 0, head over. So these have a 1/2 x. Head to the right, root 2 over 2x value. Head to the right, root 3 over 2. Head to the right, finish at the x1. Okay, so that got me through that pattern. Repeat to the left. So if I move left, then these coordinates have a -1/2. Move left, negative root 2 over 2. Move left, negative root 3 over 2. Move left and finish at -1. Okay, and then repeat with y's. So now I kind of put my fingers here. 0, move up, 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 finish up. So up to 1/2 on those guys. Heights, heights, root 2 over 2 height. Root 3 over 2 height, top height 1. Okay? I'll let you finish that out. Okay, this all very memorized. Make sure you have this ingrained in your head at all times. Lots of questions pertain to this unit circle. Okay, don't forget to understand things about each quadrant. Like for instance, this quadrant should be positive, positive. This quadrant should end up negative, positive, right? That's a thing you can look for when you're done. Also, what else can you do? You can make sure your 0 and 1s got partnered together. You can make sure those two get partnered together in a coordinate, and you can make sure that these get partnered with themselves, right? Those are all the other patterns.